Today we're going to do section 6, unit 1, solving absolute value equations. So hopefully this will be mostly review. You did this in Algebra 1. We're just going to kind of recap and maybe add some new things today. So let's look at the first section, properties of absolute values. So all we got to do is simplify the expression. So number 1, the first thing you always want to do on any absolute value equation is to get the absolute value, or the bars, by themselves. You got to isolate it. So I want from here to here alone and everything else on the other side. So which means we have to move the minus 4. So to move something to the other side of the equation, we simply do the opposite. So that would leave me with absolute value of 2x minus 1 equals 5 plus 4 is 9. Now, once we have the absolute value by itself, you want to split this up. So I'm just going to write what's inside, 2x minus 1 equals positive 9, and 2x minus 1 equals negative 9. So notice we have a positive and a negative of the other side. So now that we have two, we got to solve them separately. So over here on the left, let's solve this one. So I'm trying to solve for x, of course, so I'm going to add 1 to both sides. So I have 2x equals 9 plus 1 is 10, and then divide by 2. So x equals 5. That's one solution, but because we have to split this into two equations, we have two possible solutions. So on the right, same thing, I'm going to add 1 to both sides. So I would have 2x equals negative 9 plus 1 is negative 8. I divide. X equals negative 4. So those are my two answers, 5 and negative 4. So kind of the same as solving equations, except you have to split it into two, because you will have up to 2 answers on these. So let's try number 2. So again, I want to get the absolute value, so from this bar to this bar, all by itself, which means that 3 has got to go to the other side. Now, because it's 3 times, I know it's times because there's nothing in between the bar and 3. Like it doesn't say 3 plus or 3 minus, because it's just 3 and then absolute value bar, it's times. That lets me know to divide. So I would have absolute value of x plus 4 equals 12 divided by 3 is 4. Now the same thing we did before, I write just the inside, x plus 4 equals positive 4, and x plus 4 equals negative 4. And I solve each one separately. So for the first one on the left, I subtract 4 from both sides. So x equals 4 minus 4 is 0. And the same thing on the right. Subtract 4 from both sides. X equals negative 4 minus 4 is negative 8. And those would be my two answers. So that's it for the first section. So the next one, solve and graph. So now we have to solve it and graph it. Now, don't worry, it's not a normal XY axis graph, it's just a number line graph. That's all we're getting to right now. So the same thing though, I want to get from this bar to this bar by itself, which means that 2 needs to move. So I'm going to move that to the other side. Sorry, 3x, absolute value, 3x minus 6 equals 7 minus 2. And now I can split it up. So I'm going to have 3x minus 6 equals 5. And 3x minus 6 equals negative 5. So I have positive and negative. So on the left, I add 6 to both sides. That gives me 3x equals 5 plus 6. Divide by 3 on both sides. Now, I can't reduce that fraction. That's okay. So I have x equals 11 thirds. That's one of my answers. On the right, add 6 to both sides. 3x equals negative 5 plus 6 is 1. Divided by 3. X is 1/3. Now, here's the only extra step we do on this part. So we didn't change anything else, but we do need to graph these. So for example, the smaller of these two would be 1/3, so that has to go on the left side. And again, this number line is blank on purpose. You can label it how you need to. So let's say that this one down here is 1/3. Then from there, I can do 2/3, 3, 4, 5, 6, 7, 8, 9, 10, which would make this other one 11. And because I have two separate points, I don't have an inequality sign. There's no range, so those would be my 2 points on the line, and that's it. I don't connect them, I don't draw arrows, nothing. That's my full answer. My 2 points and, well, my 2 numbers and my 2 points on the line. That's it. So let's try one more time. On 4, I want to get absolute value by itself. Divide by 5. So I have x plus 4 equals 3. Oh, sorry, absolute value, right? Now we can split it up. Positive and negative, and we solve. So we got -1 and subtract 4. -3 minus 4 is -7. Okay, same thing. This number line is blank on purpose, so you can put it wherever you want to. So let's go -7 right here. So 6, 5, 4, 3, 2, -1 right here. And that's it. Solve for x, plotted them on the graph, and we're done. Okay, let's go to the next section. Solve equations with 2 absolute values. So notice we have absolute value on the left and on the right. So we can go ahead and, since we have no numbers outside, in other words, I have this absolute value and this absolute value, I have nothing's out here, nothing's in front, nothing is behind this one, and nothing's in front of this one. So I have no other extra numbers, that I need to get rid of or worry about. So I'm going to go ahead and just jump right into splitting this up. Now you might be wondering, how am I going to split this up if they're both absolute values? There's a simple way you can do it every time the same way to make it easier. Always keep the left side the same, and then equals the right side. And then on the next one, you do the left side the same, don't change it, equals, and then you put a negative with parentheses, and then write the entire right side. So this is how you have to do these. You can do one or the other, it really doesn't matter. You can change the sides on each one. You can do it every time differently. But if you find one way, I would stick to the same way so it's the same every time. It makes it easier. So let's do the left side first. Of course, I got to solve for x, so I'm going to move the smallest x first. You don't have to, but that does make your x's always positive, unless they end up in 0. So then I subtract 4. So I have x equals negative 10. Okay, on the right side. So on the right side, you first have to distribute this negative that we put in the front. So I would have 2x plus 4 equals negative x plus 6. And I'm going to go ahead and move the smallest x again. That's how I always do it. You don't have to, but it makes it a little easier. Subtract 4. 3x equals 2, divide. So I have x equals 2/3. Now all I have to do is put this on a number line. So again, I don't have to even number these necessarily. I can just say down here is negative 10, and since this is a fraction, it'll be somewhere in the middle, 2/3. And that's it. Because it's a fraction, though, you can't put it on the vertical line. Those are supposed to be whole numbers unless you're doing all fractions. So if you have a mix, I would just do that. Alright, here we have two absolute values again, but now we have this extra number in the front. That's okay, that doesn't mess us up any. So I'm going to do the same thing starting out as we did before. I keep the left side the same, keep the right side the same, and now instead of absolute value we want to use parentheses because we will go ahead and distribute. And then on the right side there's two ways you can do this. I'll show you one that, so we throw a negative out in the front with parentheses. Well, since we already have this number in front, I'm just going to make that number negative because the parentheses are already there. Now the other way is just flipping all the signs inside the parentheses. Either way you get the same answer. But since we have the 4 out front, I'm going to go ahead and just change that, and we'll go from there. So left side, distribute. So now we're just doing PEMDAS, right? 3x plus 2 is 8x minus 12. Move the smallest x. So I have 2 equals 5x minus 12. Add 12. And divide. So divide by 5. Now that doesn't divide evenly, so we just leave it, right? So I have 14 over 5. That's one of my x's. Okay, now we go over to the left side. Same thing. Distribute, only this time the 4 in the front is negative. That's the only difference. So I got negative 8x plus 12. Now, the negative 8 is smaller, so I'm going to move that one. So 11x plus 2 equals 12 minus 2. 11x equals 10. Divide by 11. And we have x equals 10 over 11. Doesn't reduce. Whoa, not 10 over 10. Okay, now you just plot these on the nice little number line here. Now they're both fractions, so if you want to, you can count it out. I'm not really going to worry about it right now. I just want to say this is 10 out of 11. Whoops, I did it again. And then up here somewhere, 14 out of 5. Now if you want to count it out, you can make it a little more accurate, but if it's not labeled, you can make it what you want. So that's pretty nice. So that's how you do two absolute values. And last one for this lesson is special solutions. Now notice it says solve and graph if possible. If possible, well, and also this whole thing is special solutions, so we're going to have two different kinds. So first thing we're going to do is, like normal, get this absolute value by itself. So I'm going to divide by negative 2. That gives me x plus 7 equals negative 3, absolute value. Now, here's where I'm going to stop, because we don't have to go any further. Notice I have an absolute value equals a negative number. Now, if you know absolute values are always positive, which means there's never a chance this could ever equal a negative number. Because of that, we are going to have no solution. Because there's no number that we could ever put into an absolute value that'll make it negative, because it's not possible. So if you ever get to a point where my absolute value is all by itself and I have equals a negative number, you can stop, put no solution, move on. And because there's no solution, there's nothing to graph on the line. That makes it easier. So absolute values can't equal negatives. If you want to write that down here for your notes, you can. If you already knew that, great, you're good. So whatever you need to write for you, write it down. Alright, my other one. Now, I mean, there's going to be something different about this, right? But we don't know yet what it is. So I want my absolute value by itself. It already is. So I can go ahead, whoops, go away. I can go ahead and write what we did before. We split it up. So 2x minus 5 equals positive 6x. And 2x minus 5 equals negative 6x. So same thing, even though there's an x there. And now I can solve. So I'm going to go ahead and move 2x over here. So I have negative 5 equals 4x. And then divide by 4. So negative 5/4 equals x. Then over here, same, well, not the same thing. I'm still going to move 2x, even though it's not smaller. I don't want to move the smaller x, the 6, to the other side, and then have to move the 5, and then go from there. So if you only have one x on one side, go ahead and just move it there. Even though it's negative, that still saves you time. So then I divide by negative 8, and I have positive 5/8 equals x. Now, I haven't shown you this before because we haven't needed to, but now I will. And this is something you'll have to look at only, let me be clear though. So only if I have an x on the other side, not in the absolute value. So if I have an absolute value on one side and I have an x on the other side, this is the only time you need to do this. I have to check my answers. These two numbers, I have to plug them into x here. Because if either one of those numbers makes this 6x a negative, that answer is no longer valid. We can't use it. So if I plug my left one, 6 times negative 5/4, right? That would give me negative 30 over 4. I don't care about reducing. My only focus here is that this becomes negative. I can't have that. Therefore, this number is not valid. It's not a real answer. It's called extraneous. So when an answer for absolute values don't work because it makes a negative, such as this one, we call that extraneous, or an extraneous solution. So negative 5/4 is extraneous. We don't count it. It works technically, but because of absolute values and how they work, and there are rules for that, we can't use it. Now let's plug in the other one. I have 6 times 5/8. That gives me 30 over 8. So notice, I don't care about reducing or what it is. I only care about that this is positive, which it is because it's not negative. So because it's okay, I can go ahead and plot that one. Now that I only have one number, I can put it anywhere I want to, and I don't care. So 5/8, that's my only answer. Negative 5/4 is extraneous. So again, special solutions, I have no solution on the left when absolute value equals a negative, and on the right, only if I have an x on the other side do I have to check for extraneous solutions. Otherwise, there's no possible way if there's no x. So if I have an x, I have to check. And that's the notes for this section.